masonries. Okay, so this is going to go over the different stone types, some finishes you can have, the quarrying and processing aspect of it, and then the uses. So there's three main types of rocks that we use, and they're called sedimentary, igneous, and metamorphic. So we'll start with sedimentary. These are rocks that are formed through the deposition of weathered rock fragments or minerals having been transported from their origin by air or water. Usually it's like rivers depositing sediments. And with this we have sandstone, limestone, and dolomite. So some fun facts about sandstone. It's a classic sedimentary rock. It's made up of sand. It's usually in environments where large amounts of sand can accumulate, including beaches, deserts, floodplains, and deltas. Limestone, which is a little more interesting, is a rock that is composed primarily of calcium carbonate. It can form organically from the accumulation of shell, coral, algae, and fecal debris. It can also form chemically from the precipitation of calcium carbonate from lake or ocean water. Limestone is used in many ways. We use it for production of cement. We crush it, and it's really good for acid neutralization. And the other one is dolomite. It's just kind of another form of limestone. It's not very interesting. Sedimentary finishes that can be...
Did you say it's not very interesting?
Yeah.
Sorry, go ahead.
With this you can do smooth, machine tooled, chatson, shop, sawn, split face, and rock face. A lot of these can be applied to many different types of stone. This is an example of a machine tool, and this rock is actually like a company's advertisement of what they sell. So
Indian limestone. That's the company?
Yeah.
Or is it? Yes.
So, it's actually just like I just looked up rock finishes. And, igneous rock types are produced by solidification of molten rock. So with these we have granite, syenite, and dorite. There's also these. There's a lot of igneous rocks. Gabbro, basalt, and andesite. And this andesite is fine grained. It's extrusive igneous rock. A lot of these are made of a mineral called plagioclase, and they're mixed with other minerals. Let's see. This gabbro is coarse-grained, dark-colored. It's intrusive. That contains feldspar, pyrazine, and sometimes olivine. The rest of them are all kind of the same. Granite is coarse-grained, and it's light-colored, intrusive. It's mainly made of quartz and feldspar and mica minerals. So all of these are kind of minerals. They're formed like when a volcano erupts or things like that. These are kind of the finishes that you can have here. A lot of stone is sandblasted. It gives it that rough texture that you see when you walk by walls. It can also be split face or round face. There's examples of these later. The next type is metamorphic rock. And metamorphic rock is rock that is recrystallized under the action of heat or other chemical or physical agents. So, metamorphic rock. First one is marble. It is non-foliated. It's produced from limestone or dullstone, so the dolomite of the first slide. And it is composed primarily of calcium carbonate, which that's because that's what limestone and dolomite are made of. There is also quartzite, which is also non-foliated, and it is this is what sandstone looks like once it's been a metamorphic process. There's also slate, which is it's metamorphized from shale, which was in here somewhere. And then there's also onyx, which is a banded variety of the oxide mineral chalcedony. This is onyx. It's very pretty. It comes in many colors. Commonly, specimens of onyx contain bands of black or white. You can also have blue or purple. Just very pretty rocks. And then there's travertine, which travertine is not a metamorphic rock. It's actually a limestone, but the book classifies it with metamorphic rocks because you finish it the same way. So the finishes available for it are sanded, honed, polished, wheel abraded, bush hammered, split face, and rock face. So this is what rock face looks like. It's a very natural looking way to leave it. And this is split face. It's also pretty natural looking. It's just a little more geometric. So now we're going to talk about the quarrying process. So the location of an operation where a natural deposit of stone is removed from the ground. There's two types of stones you get from quarries. You get dimension stone, which is large, big blocks of stone, or aggregate. Some things that dimension stone are used for is carvings, sculptures. People will buy a big block of rock and then carve out of it. You can also cut it into smaller sizes. This is what all of the processing plants use to cut down to get the rocks that we see that go into our curtain wall systems now. And then basically anything that you can't use to build with becomes aggregate. So any unusable rock is aggregate. A little bit about the history. The first quarries used pretty primitive tools, picks, axes. They had a lot of manpower. It was free, so they used it. And
They weren't free, they were slaves.
Yes. It was free to the people who wanted to build things. They got pretty inventive. They used some pulley systems, and they made it happen, and we're still studying it today. Current quarries use modern machinery, and they can get pretty accurate with our machines, and they speed up the process a lot. Okay, so here is how a typical quarry works. First, when they pick their site, they find a lot of rocks that they like. Then you have to remove what's called overburden and plug. So overburden is dirt or vegetation and rocks, not of the kind that you want, that you have to pull off the top. So it's a lot of digging in to find the rock that you are wanting to quarry. And then plug is the rock you want, but it's the bad parts of that rock. It's not commercial quality. So once you take that away, this can take months. It's a pretty long process getting this done. It's a lot of just, you dig until you find something you like. A lot of times they have to make roads to get to it. It's a pretty long process getting this first step done. Then you move to extraction. So in the extraction process, a lot of how you cut the rock determines what you're going to use it for. So for instance, if limestone is cut with the flow of the source stone, it's called vein cut. And vein cut highlights the movements of the rock. Alternatively, if the block is cut against the vein, cross-cut, it creates a more uniform look for the stone. So it depends on what the quarry manager wants the stone to look like, on how they cut the rock out. It also depends on the type of rock. Sandstone is actually cut along the bedding lines. So they take a forklift and they find a bedding line and they basically just pick the rock up and they carry it out. They'll take that and they'll take it to the processing plant, and I'll talk about that in a second. But anything that's not usable is stored on site, and they use it to backfill the quarry whenever they're done. Obviously, this doesn't fill up a lot of the quarry, and a lot of these quarries are dug beneath ground level, so a lot of them turn into lakes, just man-made lakes. Some of them have been converted into like swimming holes. It's kind of dangerous though because there's a lot of equipment that they leave in the bottom of these quarries, so they're that's the byproduct of quarry rock. So the processing plant is where the stone is cut and finished for its purpose. There are many methods. A lot of the methods depend on what type of rock you're using and what you're using it for. Historically, people would, this would all be done with axe, picks, hammers, chisels. People got really good at it. They got very accurate. There's some places they say that you can't even stick a knife between the blocks because they're cut so accurately. Currently, we use modern tools and technology. We use a lot of these saws and drills with water. They have to apply water because the rocks get so hot when they're cutting them that things can catch on fire and melt. A lot of stone is natural, so also every stone is different. You can't cut everyone the same way. They don't all look the same. The current processing flow chart. So first thing you do, once you have taken it to the processing plant, you do what's called a primary cutting. And this is basically cutting it down to like a workable size so you can use it. Usually you use like circular blade saw to do this, get it in some nice sheets. Then you can finish it, and if you're doing things like rock face or split face, usually the process ends here with this finishing, and then you just ship it out. If you're doing more accurate stuff like marble tabletops or headstones or things like that, you're going to have to do a secondary cutting, and it's just polishing up the stone, just getting it nice and ready. You package it and you transport it, and then whatever you cut off of the stone is also transported either to the on-site to use for backfilling, or it's crushed and used for aggregate. Now, this is kind of the requirements, and I know we have somebody else that's giving reports on these, so I didn't go too far into it, but if you want to look at them, they're also in the book. So a lot of stone, historically, they were just stacked. They made fences out of them. Then they started using mortars to hold them together. Historically, they were load-bearing walls. However, currently, we're using them as curtain walls or a facade system. So we don't really use them for their natural strengths anymore. So if you are going to use it for your strength, you want to make sure you put the load perpendicular to the rift. And the rift is what forms when the rock is forming the different layers. That's a rift. And if you put it parallel to the rift, it can shear off, and it's not as strong that way. You want to put it perpendicular. And then here's some physical properties. If you want to check it out, there's a site here that has some good math. It kind of goes through the math of everything. And then this is one of the greatest stone masonry feats. And there's no sources. Do you have any questions?
Yeah. Go ahead.
So when you say they're using...
You made it just in time, too. I was getting ready to cut you off.
If you say, you said they're using curtain walls, how do they utilize stone?
I mean, I didn't look into it very deeply, but they basically just make panels and hang them up.
Yeah, especially granite, your high end, they'll make anywhere from 1.5 to 2.5 inch panels, and they'll put them up. Limestone's the same way, maybe a little bit thicker. And they'll have inserts to attach it.
So it's just solid stone, right?
Oh, yeah.
We're not talking glass here. That's what I was confused about.
No, they are curtain walls, though. They are curtain walls because a curtain wall is hung.
Right.
Yep.
So, yeah, they're constructed the same way. They're not stacked, like stacked stone. They're hung because they're larger sheets. What's the normal strength of really good granite?
Really good granite?
Yeah. No, I don't. I was just asking you.
I don't know.
Oh, well, I gave you a problem, an analysis on that, and, you know, didn't I give you that problem with the obelisk? And,
Yeah, like
Oh, yeah, you did.
and that was really good granite.
Lots of Pascals.
It's about 8 kilopascals. There you go. It's about, yeah, that's right. It's really, okay, very good.
Bonus question.
How long do, I don't know if you'll know this, but how long do quarries usually last? Can they quarry it for a while?
So
Or
the
is it
stone's
just,
gone. It's not receiving.
Well, you guys have been
So
going
it
to that
rains
quarry
and
in
it fills
Kansas
in.
for years now, and you guys go up there in they go up there in third year and second year, or whenever they go up there, so.
you know?
I mean, we could-
Well, I know you don't.